Hello, my name is Professor Overton. This is Discrete Structures. Uh, what are we going to be covering in this class? Functions, sets, relations, proof techniques, propositional and predicate logic, counting, and a few other topics. Basically, I like to see this class, I like to look at this class as formalizing common sense. Logical arguments, that sort of thing. Things that we understand and know intuitively are formally outlined in mathematical terms in this class. We'll look at function sets and relations and use them in proof techniques using propositional and predicate logic. And counting is thrown in there because computers have a tendency to use get into large numbers, and the ability to count large numbers quickly and efficiently helps things along quite nicely. So I made sure to include counting in the chapter on counting in the curriculum for this course. What you need to know. You should take notes, ask questions, and communicate with me. If something's going on and I don't know about it, I can't respond accordingly. I will allow notes on quizzes and tests. I will, as you can see, record the lectures, and I will be available outside of class. What makes up your grade? I believe attendance is an important part of your grade, so I include it as 10%. 20% for quizzes, 25% for homework, and 45% for in-class exams. So the homework is assigned on a chapter-by-chapter basis. I believe they're all posted at this point on Canvas. Feel free to get ahead, do things, do homework as you get the concepts. The homework will be due before the quiz or exam for the chapter that it's on. The slides that go along with the textbook are on Canvas as well in the files section. So you can follow along on your laptop or tablet during lectures, or if you want to see a little bit different way of looking at the topics that I present, you can look at the slides independently as well. You can download them all. We're only covering chapters 1 through 5 and chapter 9. There will be an opportunity for extra credit. I'll get into that a little bit later. What you should be doing this semester. Attend class. Getting a good grade is virtually impossible if you do not attend class. If you must miss class, let me know. I will try to work with you and keep you caught up to speed and on track. I had a student, I've had a student or two before complain about their grade at the end of the semester, and I look at their attendance record and I see 48% attendance. I was like, you're there less than half the time and you expect a good grade? Not likely. So they didn't get the grade that they wanted. So attend class. I will work with you if you can't. Just let me know, and don't make it habitual. Take notes. Taking notes helps you absorb the material. You will be allowed to use the notes on quizzes and exams. Printed material is also allowable. I in the previous class didn't make myself clear, so I'll try to make it more clear this time. Notes for quizzes and exams have to be printed on paper. It could be handwritten, it could be computer generated, it doesn't matter. It just has to be on paper. Laptops and tablets are not allowed to be used on quizzes and tests. So, just to be clear, it has to be printed notes on paper. Ask questions. If you do not understand a concept, ask questions and I will try to reword the material. If you don't ask, I'll assume you got it and move on. Some people think the only stupid question is the question that's never asked. I disagree with that statement. Little story, I was in a grocery store one day, and I was by the sodas, and this lady comes up to me and looks at me and asks, straight face, honest, how many are there in a 12-pack? Okay, the question that answers itself is a stupid question. So just think about the question. Does it answer itself? No? Go ahead and ask it. So, just if you don't ask questions, I'm not going to know that you're not getting it. Let's see, why is it important to take notes? Processing. You have to process the information to put it down on notes. Typically, you condense what is presented into written form, whether it's typed on a laptop or written on a piece on a notepad. That takes processing on your part. That helps you understand the material better. So just the act of taking notes is a form of studying. You're better off taking notes, detailed notes during class, and throwing them in the garbage on the way out the door than just sitting there doing nothing and just listening. It is important to take notes because of the processing that is involved in the act of taking notes. Organization. If you take the attitude of, well, my friends are going to be taking notes, I'll just photocopy their notes and I'll be fine. Not necessarily. How they organize notes may be different from the way you would organize notes. So you'll be fumbling around trying to find the information you need during a quiz or test, and you don't know where it is because it's not organized the way you would want it. So taking notes keeps you organized so you can find the information quickly and efficiently. And again, they are allowed on tests. Paper notes are allowed. If you take notes on a tablet or a laptop, make sure you print them out before the quiz or test. I typically give 1 or 2 class sessions at least notice before a quiz or a test. So you have plenty of time to print out computerized notes before the time of the test. What I will do this semester: allow notes, we've covered that. Record lectures. Lectures will be recorded for you to review, or if you miss a class, you can view the videos in your own time. Videos will be uploaded to YouTube within a day or two of the lecture. Just a little caveat, I'm having some software issues, and so the next few lectures may not make it to YouTube for a week or two. I'm not sure when things will get resolved, but I'm working on that. I will be available. I make helping students a priority. That is my job. I am an educator. Educating means helping students. It's not just getting up here and me spouting information for you to magically absorb. I'm here to, explain things that aren't clear. Work with you to get you to understand the material. I'm usually on campus by 8:30 in the morning, Monday through Friday. And although I am an adjunct professor, which means part-time, I am here full-time hours. So I'm here typically until 3 or 4, 5 o'clock in the afternoon. I have stayed until 9 o'clock helping students before. So, I am willing to make myself available. If you need help on a weekend because of something coming up during the week on Monday or Tuesday, I can typically be available on the weekends as well. I don't generally make it a habit of being up here, but I can. They don't lock the building up on the weekends. We can get in and we can go to my office and we can work on things. Generally, if I'm not in class, I am available to help. So I will make myself available. I am understanding of special circumstances. If you need any special accommodations, just let me know. Whether it's disabilities, sports, band, student organizations, travel to conferences, interviews, that sort of thing. Please just let me know how I can help and what kind of accommodations you might need, and I'll be happy to work with you. Sports and band. A lot of students are scholarship students related to sports and band. So, you got to go where the money is. If a band obligation takes you, to Louisiana for 3 or 4 days, you got to go do that because otherwise you might lose your scholarship and get kicked out of school. Priorities. I understand that. Student organizations. Student organizations will do competitions and other things where travel is necessary. I can accommodate that as well. Like I said, I record my videos. You can watch them, watch the lectures when you're available to. Travel to conferences, I think, is an important thing to mention. If you get an opportunity to travel to a conference, I say go for it. It's an opportunity to network, get to know people, possibly get job interviews or internship opportunities, that sort of thing. From a cultural standpoint, it's an opportunity to see how other people live. different parts of the country or even different parts of the world. My first conference when I was an undergrad, I went to Africa for 8 or 9 days. That was a different experience. How do people in that part of the world live? It's not something you really get a feel for watching a documentary on PBS or whatever, or National Geographic Channel. Going there and seeing how people live in different parts of the world or the different parts of the United States even. It is an educational experience in and of itself. Job interviews or internship interviews. Again, it's go where the money is. Internships are a valuable part of the education process, and you got to do interviews for those and that sort of thing. If you have to miss class for something like that, or a career day that they have every fall and every spring, please go. Opportunity to meet people, network, and possibly land a job or an internship for the summer. So definitely a valid reason to miss class. Just let me know what's going on, and I'll work with you. Let's see, any questions? Oh yeah, tests and quizzes are on paper. That prevents the ChatGPT answers. No computers or tablets used on tests for notes or for taking them. You are allowed calculators, especially in the counting chapter. We'll be running some numbers through the calculator and that sort of thing. So those are allowed. But yeah, paper tests and quizzes. Depends on the chapter. Like well, let's see here. Well, let me do the last slide, and then I'll look something up for you. My office hours officially are Monday, Wednesday, Friday, noon to 2. I'm typically, like I said, typically here at 8:30. So anytime before noon, Monday through Friday, I should be available. So feel free to knock on my door. I need to add to the slide, my office location is room 237. It's up in the department office suite. Everybody know where Miss Seaton's desk is? Miss Jessica? Up in the office suite up on the second floor. My office is the second door on the right. Yeah, Dr. Humos's office and then mine. So that's where I'm at. This is my email address. A lot of people just reach me by email through Canvas. That works fine too. That gets routed to my email address. So no big deal there. This is my personal cell phone number. Please don't abuse it. And nobody has yet, but I don't want to start anything. If it's an emergency or something comes up or something like that, you need to talk to me quickly. Text me first to let me know that you're going to call, so I don't ignore your unknown number. So you can reach me that way as well. But let's see here. Let me. Chapter 1. Oops. is only 4 sections, so that'll be about a week. Chapter 2 is 5 sections. That's a week and a half, 2 weeks. Chapter 3, I think, is chapter is a short chapter. Chapter 4, that's the big one. Yeah, 10 sections. So this one would be about 3 or 4 weeks before the test for this one. It just depends on the chapter and the size of the how many sections and how long it takes to get through all the sections to do that. But all those slides are on Canvas in the Files section. So feel free to download and view those to see a different way of expressing the content. Use them for reference while you're doing the homework. That sort of thing. Let's see here. Anyway, let's see here. I think that about wraps everything up. Was there any other questions? No? Okay. We'll jump right into chapter 1 then, if you want to get your notebooks out and ready to go. We'll cover chapter 1, section 1. All right. Chapter 1 is called Speaking Mathematically. And we'll start off with talking about variables. Now, using variables gives you the ability to refer to quantities unambiguously throughout an argument. So, A equals such and such, B equals the other thing. It's consistent throughout the argument if you just refer to it A, B, and that sort of thing. But it's a place. But variables, in essence, are placeholders. They can be used for statements. They can be used for numbers. And they can be used for Boolean expressions. I don't know if everybody's gotten to the point of knowing what a Boolean expression is yet, but we'll get into those later on in the semester. But if you've had digital logic, and I suppose if you've had CSC 1, computer science 1 or 2, you should know what a Boolean expression is. Variables are used when you don't know the value. That's often how you see variables in algebraic terms. You don't know what x is, so you solve for x, so you do know at the end of the argument or the end of the discussion. Of course, there is also the time when there are multiple values that satisfy the expression that you're dealing with. Take, for example, y equals 2x plus 3. X and y can have infinite number of values. There's a relationship between the two given by the equation, but there are an infinite number of values that x and y can be. And finally, variables can make a statement more general. So take the statement, I think I had an example here. Are there, well, if you attend class, let A, B attend class, B equals good grade. If A, then B. This is a situation where the variables are placeholders for various or for different statements, and you'll see the form if A then B several times through the course of the semester. This holds true for various values for A and B. So the truth values for this statement would be the same. For example, if A were eat rotten food and B equals get sick. If A is true, then B is true. If you attend class, you get a good grade. So it makes a statement more general for manipulation and evaluation. Another example. Are there numbers with the property that the sum of their squares equals the square of their sum? So, are there numbers with the property that the sum of their squares equals the square of their sum? So, you would write it using variables. Are there numbers A and B such that A squared plus B squared equals A plus B squared? Okay, so You can see, when reading the statement, are there numbers with a property that the sum of their squares equals the square of their sum? It's like, okay, what exactly does that mean? When you write it out as an equation using variables, it's a little bit more clear. It's more concise. It's unambiguous. Given any real number, its square is non-negative. Okay? So you would write that as for all real numbers R R squared is greater than or equal to 0. Using symbols and variables to make it more clear, unambiguous, more mathematically formalized. Okay? So there are some important kinds of mathematical statements. Oops, wrong direction. There's the universal statement. A certain property is true. For all elements in the set. That is a universal statement. It's true for all elements in a set. So going back to this one, for all real numbers R, that's the set that you're dealing with, this property is true. That's a universal statement. A conditional statement if one thing is true, we lost lights. Come on, there you go. All right. If one thing is true, then some other thing must be also true. So you have the if and then for the universal statement you have all. Finally, you have the existential statement. Okay? That means that there is at least one thing for which the property is true. For at least one is the operative word there. Operative words. So those are the three types of mathematical statements that we will be running into. Bless you. Now these can be combined in various ways to make more complex compound statements. For example, you have the universal conditional statement. It is a statement that is both universal and conditional. Best explained through an example. So, for all animals, A, if A is a dog, then A is a mammal. So it's for all, which is universal. If, then makes it conditional. So it can be rewritten ways that make them appear to be purely universal or purely conditional, like the conditional, if A is a dog, then A is a mammal. Or universal statement, all dogs are mammals. So, but this is the universal conditional statement. Kind of a compound statement there. The next kind of type is the universal existential statement. Has two parts. First part says a property is true for all objects of a given type. The second part asserts that it asserts the existence of something. The existence of something. Okay. So Example again. Every real number has an additive inverse. So every real number, yeah, qualify that. Real number has an additive inverse. So every indicates that it's universal for the set of all real numbers. Has an indicates the existence of something, the additive inverse. It can be written several ways, some formal, some informal. The informal would be something like all real numbers have additive inverses. Something more formal would be for every real number R, there is a real number S such that S is an additive inverse for R. So, yeah, it's a universal and existential. So how can you restate the statement, every pot has a lid, less formally? How could you restate that? All pots, every pot has a lid. All pots have lids, yeah. Yeah. More formally, you could say every pot P has a lid L. You know, using variables where you don't know which pot you're talking about, but there exists an L lid that matches it. Now we have also the other way around, the existential universal statement. Again, you have two parts. First part says that a certain object exists. The second part says that the object satisfies a certain property for all things of a certain kind. So, satisfies, let's see here, a certain property for all things, all things of a certain kind. So, example of that. There is a positive integer is a positive integer that is less or than or equal to all positive integers. There's a positive integer that is less than or equal to every positive integer. Is that statement true? Is the statement true? There is a positive integer that is less than or equal to all positive integers. Yeah, which one? One. It's less than or equal to all positive integers. All positive integers start at 1 and count up from there. So the number 1 satisfies this equation. But it is existential because there is a universal, because it is to all. So it is a existential universal statement. So less formal way of saying it, some positive integer is less than or equal to every positive integer. What about there is a person in my class who is at least as old as every person in my class. There is an oldest member. There is a person that is the oldest in the class. Is a less formal way of saying that. But there is a person, existential, who is at least as old as every person in my class. Universal. So it is existential and universal. I'm going to finish up with a little bit more complex one. Everybody remember cow 1? Off the top of your head, just kind of, you know it like the back of your hand? Have nightmares about it? Oh, well, I mean, so the definition of of the limit of a sequence, the limit of a sub of n as n approaches infinity is L. but it can only be defined using phrases that are universal, existential, and conditional. So, let me hold this so I don't get it wrong. For every positive real number E, there is an integer big N such that for every integer little n, if n, little n is greater than big N, then minus E is less than A of N minus L, which is less than E. Remember that from Cal 1? Yeah, it's easy stuff, right? Like I said, do you have nightmares about this? But yeah, it's universal. So for every, there is an integer, existential, universal again for every integer, and then you have the conditional if, then. So it is a combination of all three types of mathematical statements. So, yeah. Well, just going to cover that one section today. Thursday we'll pick up with the language of sets and that sort of thing, and maybe relations and functions. We'll see how things go come Thursday. But in the meantime, have a good weekend, or not a good weekend, a week. See you on Thursday.